This is an application written for Pocket APL by Richard Procter. Richard comes from 20 years of APL and has extensive experience. So here you go.
Thank you. Is this working? Everybody here? Okay. Right. The application I'm going to talk about is written in Dyalog's Pocket APL. And for those of you who have never seen one, these are the devices that we're talking about. They are Windows-based operating systems on what has been called Pocket PC, or Windows Mobile is now the term they use for them. And they've gone through several iterations of the operating system itself over the last several years, and that's actually one of the issues I'll be talking about. The first ones we started working with were rather slow and limited in memory and so on. So that was another one of our challenges. But let me just tell you first a bit about the application. I do this work very sporadically. The company that I'm talking about here is called Mealtracker, and they are in the business of providing meal planning software for retirement homes and nursing homes in the U.S. So the idea is that retirement homes, nursing homes, they have seniors and disabled persons and so on who are typically eat in a cafeteria or in their rooms, in fact, and they're served food on a tray. And so, and typically they have, fairly, difficult. Some have difficult dietary requirements. Some are diabetics. Some have to have their food, more fully cooked than others, and so on. So the database that Mealtracker has designed and the system they've designed helps these facilities plan the meal planning or work out the meal planning, so they can input information for each resident in the facility to suit that resident's requirements exactly, or as near as possible, and match that with a database of recipes and food, inventory on hand, and information they get from their food suppliers, including, which is very interesting, including detailed nutritional information that comes with the food that is supplied. So for a given meal, of course, from what I understand, it's a requirement for these facilities by law to make sure they are serving adequate nutrition to all of their residents, and that, of course, makes sense. But how do you determine what is adequate, or whether you're in fact providing the adequate nutrition? So that was one of the driving forces behind the software. And so having a nutrition database essentially with the food that's supplied allowed us in a software way to look at a given meal, for example, and analyze that meal according to its content nutritionally. How much carbohydrate, fat, protein, etc. And there's in fact a list of about 72 ingredients or components of nutrition that are monitored in this case. So it's quite a detailed level of monitoring and proactive design that goes into this. This is there's two components to the system here. One is what I call the base system, and that is or was written in APL plus Win. So this is one of the screens. Sorry, that's not showing up too well. This one on the top left is one of the screens. It's basically the main menu of the base system. So essentially, a nutritionist at these facilities would type in or collect data for all of the residents in the facility, and so their names and their room numbers and their nutritional requirements would be stored here. And also their likes and dislikes. Maybe they don't like coffee in the morning, maybe they don't like cereal, and so on. So those sorts of things are all, there's input areas for all of those things. The design, one of the design philosophies of the whole system here was that you're putting this software into nursing homes, retirement homes. These are not software-driven places. They are, in fact, software is typically one of the last things they know how to deal with. They know how to deal with people and nutrition and food, but not necessarily software. So we wanted to design the interfaces to be as simple as possible for anyone to use. So in fact, I joined the team sort of, I don't know, midway or later in its development. And I had a lot of great ideas. Well, you could improve this and improve that. And they just shot me right down. They said, no, we don't want anything fancy or complicated. We want to keep it simple. So that's been the design principle throughout. Eventually, though, as I said, we developed this, what I call the nutrition module. It's a little fuzzy there, but basically what you have here is as I said, a list of 72 nutrition factors, such as carbohydrate, fat, and so on. So for a given recipe, we have over here something like a breakfast with oatmeal, cereal, coffee, and eggs, perhaps. And we can take that information from the recipe, match it to our nutrition database, and come up with, this is essentially a histogram on its side. So for each nutritional item, we can tell, and this line here, this dotted line, represents what we call the daily, the recommended daily nutrition for that item, how much that person should have in their meal. So the question is, are we meeting, for every one of those ingredients, are we meeting a 100% required nutrition or not? And if not, then of course what you can do is add a supplement to the meal. You can add these protein drinks, for example, to have more protein and things like that. If you're overdoing it, of course, then you're kind of wasting money, by the way. And if you're overfeeding, before this sort of detailed level of monitoring was available, I think the strategy was, well, basically we'll just overfeed everybody, and then we'll assume they're getting adequate nutrition. So this is a more focused approach, more detailed way of arriving at that. So once we had developed this module, this sort of came second after the main base station level. The question was, okay, now that we've fed people what we think is adequate nutrition according to our model here, what if they don't eat it? What if we actually serve a tray of eggs and they only eat half the eggs? Well, then they're really only getting half of the nutrition, aren't they? So we started scratching our heads and saying, okay, we need some sort of way of monitoring consumption. It's not just what you serve, it's what they actually eat that's important. So then we thought, okay, how are we going to do that? We could send someone around with a piece of paper and look at the tray after the person has had their meal, and try to come up with some assessment. And the people I work with, they didn't quite have an idea how that was going to work. They were thinking, the nutritionists, how would they actually input that data? Obviously, just scribbling it on a piece of paper is not going to be very effective. What about a barcode? Could they scan a barcode, perhaps, to indicate something was fully eaten or half eaten or quarter eaten or so on? So I thought about that a bit, and around that same time, Peter Donnelly came and visited us in Toronto and demonstrated Pocket APL for the first time. And a bell went off in my head. I said, oh, wait a minute, we could design an APL program for this. We could send the nutritionist around with one of these handheld devices, and it would, of course, be able to have exactly what was served to that resident, and then allow us to tick off, essentially, what percentage they may have left on their tray for each item that they were served. So here's a meal here. And by clicking on, as you click on these buttons, this is your input area, essentially, you determine what number goes in here. So this is essentially a very restricted keyboard. And as it fills in this number and you click on that, fills in that number, then it cycles to the next one and the next one and so on. So you can easily, or you can just simply tap on one of these items and that will highlight this box, then you can change the number. So this is a design criteria throughout, is we had to keep it as simple as possible, try to minimize the number of clicks that the input person and nutritionist would have to do. So that was the strategy. I'll tell you a bit about the company. It's called Mealtracker Software. This is their web page. They're relatively small, only a handful of employees, in fact. The base product was in APL when they're now migrating it to other platform tools, including .NET, and there are various business decision reasons for that. I don't think they've fully finished that job yet. But the Pocket APL module was developed around 2003 for the first phase of it, and we're still sort of fine-tuning it, I would say. They do have about 1,000 installations of the base station around the country, of which I understand only about a dozen are using the Pocket APL module. It's sold as an add-on module to the product. So not all of the facilities have taken it on yet. And one of the reasons they haven't all taken it on is because that actual nutritional monitoring section I mentioned with the histogram, that is also a software module, so not all of them purchase that either. So if they don't purchase that, then they really don't need the Pocket monitoring either. So the company has to start, I understand they're going to start bundling everything in together. So I think we're going to be seeing more deployment of the Pocket module soon. Okay, so that was our first application where we wanted to monitor what did people eat. We call it consumption monitor. Then that went out for a while. That went out for a year or two, and we got feedback from customers on it. And a lot of the facilities that were using it said, well, that's kind of interesting, and I guess if we had that nutrition module, that would work for us. But what we really want is something to be able to go to allow our nutritionists to go room to room and ask people what it is they want for breakfast, lunch, dinner tomorrow. So in other words, just a menu order taking facility is what, and it turned out that was actually really in demand as opposed to the thing we thought would be in demand. So that, I'm sure a lot of you have been through that process with software development in the past. So we sat down and spec'd out a menu order-taking facility, and this is pretty much the screen we came up with. So you see a drop-down list of residents or room numbers, breakfast, lunch, or dinner, which meal are you talking about, and you might have multiple days you want to store that information for. And then we have food items for, say, breakfast, organized by category. So you've got an appetizer section, entree, bread section, and so on. And as you just simply click on those food items, the red arrow will come on or off to indicate that, yes, that's a selection that I want to make or not make tomorrow for that person. And then when you're sort of done that input part, you click Save, and that sort of updates that bit of information for that resident, and then it automatically cycles to the next resident. You walk to the next room and you start the process over again. So that's generally how it's meant to work. So what are some of the challenges and so on that we've had? Well, first of all, as I said, these devices are limited in speed and the amount of memory you can use, and the actual size of the screen, of course, is one of your main limitations. The original devices we were using are 240 by 320 pixels, so that's all you've got to work with in terms of screen size. And of course, you want to make things as visual as possible, and as I said, as simple as possible. Fonts, there's a limited selection of fonts as well. Now I suspect some of those limitations keep getting worked on and are disappearing, but generally speed, screen size, and memory are going to be with us for a while. Compared to the desktop environment I'm talking. The GUI itself, the way we do this development is we develop, of course, on the desktop itself. We try to emulate what we're going to see on the screen, and I'll show you an example of that in a minute. And then we port that to the device. We don't develop on the device itself generally. We may do a little bit of debugging, but it's very hard to do debugging. And if any of you tried that little keyboard, it's, especially as you get older and you need glasses and so on, it gets more difficult. So that's one of the issues, though. The GUI components that you tend to develop on the desktop don't always translate perfectly in terms of alignment on the screen. That's one of the challenges that I've had. But it's not bad. And functionality as well. We had some issues in early days, and we still do, I suppose, in some ways. We found, for example, that the menu, if you had a GUI form with a menu, I forget which version of APL it was. Perhaps the first version of Pocket APL worked fine, and then there was a change of the. It worked fine with whatever version of the operating system we were at that point, Windows Pocket PC, whatever number it was, I forget. And then along came something called Windows Mobile 5, and suddenly we lost our menu. So that was a challenge. We had to come up with a way of, emulating a menu, and so we created some label GUI objects, and we put little pop-up callbacks on those. Applications don't close exactly the same way as they open and close on a desktop, so that's an issue you need to deal with. But one of the main, another one of the main challenges was what I call interruptions, or just what you're talking about, Richard, when the system, the operating system packs it in. That is a challenge with these things because, of course, batteries can run out of power, or people can drop them on the floor, or suddenly the back opens and the battery falls out. Things like that have happened, and we have had some issues with files getting damaged. In fact, that came up once with a customer, and I believe the way I dealt with it, I didn't know anything about file journaling, so the way we... Pardon me? No, exactly. The way we dealt with it was, what I thought would avoid it in the future is I simply, I do write to a component file for storing some sort of, the temporary input basically goes out to a component file. And what I decided to do is simply untie that file every time I'm sort of finished writing to it at a certain stage, and that seemed to fix the problem. Does that make sense?
It does, because the other time does the F6, which brings everything to the disk.
There we go. Problem solved. Now, of course, that wouldn't work in a multi-thousand transaction environment, but it works perfectly well for here. Okay, so those are just some of the simple little challenges we found. This is what the Dyalog screen and keyboard looks like when you actually get the device up and running. So if you've never seen that before, that's it. We, as I said, we develop on the desktop, and we test it on the device and then deploy it as a runtime module. So we try to mimic the PDA environment on the desktop, and to do that, Ray Cannon, who, as you know, some of you may know, is I would consider a guru with the Pocket thing. He was playing with it a long time before I started doing so. He's developed a whole suite of utilities for running applications on these devices and running them on the desktop at the same time. His utilities are built to take one path or another depending on which device they're on. And many of his utilities use Quad NA in order to affect certain operating system level tweaks and so on, and they're very handy, so my hat goes off to him. One of our design principles, I said, was keep it simple, keep the interface the interface to the user simple, and our own development environment simple, because I'm just a hired consultant to this company. In the end, they wanted code that they themselves could read and handle quite clearly. They didn't want me writing unintelligible code to them. So I had a duty to keep things fairly simple on an implementation level as well. One of the latest challenges we have is the screen size. The newest devices are coming out now, and they are double the number of pixels. So from 243/20 to 480/640. Well, it turns out I didn't anticipate that, and all of my code now needs a rewrite. So I've got to go back and find all the places where I'm setting the size of buttons and positions of things by pixel number, which is pretty much everything. And I've got to now generalize that so it picks up a factor or some sort of scale factor that will allow me to calculate those positions rather than generate them hard-coded. So that's my latest workload on that. The keyboard pop-up, that's another little feature that you don't have to deal with in the development environment. Okay. So this is kind of what it looks like now. We still have the base system. When you start up the system to begin with, you see this screen. Do you want what I call the consumption monitor or select menus, or just quit? One of the things I put on the little pop-up screen, the splash screen, is the workspace size, because we had some issues with dealing with a large number of residents and their data, and we ran out of workspace. So I wanted to make sure that of course, in the calling instruction that fires up the application, that the workspace size is sufficient, so I put it on the screen to get that kind of feedback if I need it from people who are using it. So the way we do this is this. The base station, as I said, keeps track of all the residents, their daily requirements, their likes, dislikes, and so on. So for a given day, say tomorrow, we generate what I call a transfer file. So the transfer file goes into the device, and it's simply a text file, and it's very similar to XML, but it's not XML. It's essentially got not tags, but delimited. It's a delimited file with sections for the resident names, the meal names, the food item names, the portion sizes, and so on. So that all gets downloaded to the device in one single file. Then you can fire up either of those applications, use the transfer file, change it, and as you go along, essentially you're changing that information, adding new selections or consumption numbers to it. And then when you're done, you've got again a text file, transfer file that goes back to the base station, and there's some more software there that takes that information and generates tomorrow's trays for instructions for the kitchen to put out for the residents. So that's one of the or does the consumption monitoring. There's depending on which application you're running at the Pocket level. So that's basically, in a nutshell, what the system does for them now. And it turns out, as I said, the nutrition monitoring has been downplayed lately. This is more the popular one that they're actually getting some good feedback from users on. Here's what the actual transfer file looks like. As I said, it's very simple. It's just a delimited file with things like the meal names, breakfast, lunch, dinner, the resident names, their room numbers, their dietary notes, as we call them, their portion sizes of food items. Every food item has a unit of measure. Is it cups? Is it ounces? Is it large, medium, small slices of toast, etc.? So that's another parameter. Finally, down here at the bottom, we have essentially an array of numeric integers, which are essentially pointers back into these tables. So everything above here is a table of some sort of information, and everything below here is our numeric pointers back into that table. So that's the design of the transfer file. Very simple. So when I get that onto the PDA, the first thing I do is I turn all of that information at the top into several large enclosed arrays, and everything at the bottom into one numeric matrix that I keep in memory in the workspace. And every time a selection is made and the nutritionist presses the save button, I then write that table out to a file. And I guess I write it both to an APL component file and a native file, just to be on the safe side. That's one of the things we did. And that it seems to work just fine. It's typically not a huge file, I guess, so we can get away with that. So there's still some issues. Sometimes there is some very large files, and I've been told to find some ways to make this more efficient. But that was a major one. That was just storing the information because as I said, you could be halfway through your data collection process, and you might have 100 rooms to go through. You don't want to get to room 50 and suddenly have the battery fail in the device and lose all the input you just collected in that hour and a half you were in those other rooms. That would be a disaster. So we want to make sure there's good security on the storage of that data. The key points, I guess, just to summarize before I do a demo, are it's turned out to be a major time saver for those facilities that have bought the module, especially on this side, to collect information for tomorrow's meals. They found that this really helps them plan tomorrow's meals. It really helps them make their residents happy, because now the residents are getting exactly what they've asked for on their tray tomorrow. So it's ideal for that. So that's great feedback. We do have some ongoing incompatibility in platform. And every time we get a stable sort of release going, Microsoft comes along with another Windows Mobile version, and we find that some things may not work with that. So that's an issue. And now, as I said, the screen size is a big pain in the neck. So anyway, it gives this company a bit of a competitive advantage. They've got a handheld device that feeds into their base station software. It helps with the data collection side of information. And who knows, maybe there's other applications out there in the world that could benefit from such a thing. So I'll just do a very quick demo of the device. I actually have a couple of them. I have a whole drawer full of them, in fact, because as I said, we've gone through several iterations here. What I've got loaded up here is some software that allows me to every time I choose or do something on the device itself, you'll see it there on the main screen. I can actually zoom that to 1, 2, or 3 times, which may be too big, in fact. Okay, that's good, yeah. All right, so this is what the main menu. I can't go too far with this thing. And there's a bit of a delay, by the way. I notice every time I tap on here, it takes maybe a second or two before it sort of shows up over there. So bear with me there. If you've never seen Pocket APL on one of these devices, you simply install it and click on the menu, and in a moment or two, up comes the usual session, the APL session. Like I said, it's not the fastest device in the world. There we go. So clear WUS. Down here we have our keyboard pop-up, and if you hit the control key, sure enough, you get APL characters. So you can enter something like out of 33, return, you get that. So you can do good old standard APL right there. I won't bore you with that. I'll just load the workspace. Now, normally, as I said, we deploy this in a runtime mode, so there is no APL session. The people simply click on an icon, and up comes this screen. And as I said, you've got two modules: consumption monitor or select menu. So I'll just go through those quickly. So you just saw some information there about the fact that it was processing the transfer file, meaning it was turning that simple text file into a set of APL arrays, and then finally building the GUI. So here's Benjamin Balser's breakfast, what he was served. Now I've gone into his room. I'm looking at his tray. Did he eat his one individual Raisin Bran cereal? How much did he leave on his tray? I'm not sure where these original numbers came from. There's an option on the base station level to set the default value for these percent left items. I could, in fact, click 8 all, and then I'm setting everything to 0. There's quite a delay. I noticed about a 2-second delay from when I type here to over there. Or if I click on 8 none at the bottom left, then it should be 100% if he ate everything. So that's a little shorthand. Or I can just individually go through and click on individual buttons, so 30% for that item, and you'll see that it cycles down to the next item, 50% for that item. Wow, that's quite a delay. Or I can skip down an item or two. Is that, yeah, mixed fruit cup is highlighted. Is it highlighted there? You can barely see it on your screen, but it's highlighted here. And click the value for that item, and so on. So it just keeps cycling through the items. So that's basically, now that at the bottom, by the way, it says File Meal Options. That's our modified menu, or our emulated menu. As I said, the menu originally, I guess. I'm not sure. I haven't tried it with this latest version on this particular device. This is a new device that I got just a couple months ago. But that's my emulated menu. So those are, in fact, label GUI objects, File Meal Options. And if you click on one of those, it comes up with a little pop-up that allows you to do other things, such as set the screen colors, for example. So we've got a little drop down. If you don't like the background color, you can change it with this. So when you've input all the information to the for that particular person, you can then just click on the Save button, and that does a little write to the file system on this device for the moment, so that I can now safely go to the next room and know that I'm not going to lose the information because it's tucked away in a file on the device now, even if the battery fails on this. And when you're done all of your residents, you simply say Exit, Create Transfer File. And what that does is it takes that transfer file again and just marks it as a finished file, I guess, and then we know it's ready to go to back to the base station and be processed for tomorrow's meals or whatever. Let me just start that up again, and we'll.
When you say it's ready to go to the home station,
yeah.
Does it go over Wi-Fi to the home station?
No, good question. As I said, these facilities are very computer illiterate, or not very computer literate. So Wi-Fi would be way beyond their capability in many cases, I suspect. Maybe not now. This was 2003, 2004. We were developing this. It would have been totally out of the question. Maybe not so much now. Maybe it's starting to get acceptance. But yeah, that's an option we'll consider in the future if possible. Yeah, but it hasn't happened yet.
But how do you get that information to the central data?
Well, you hook up this wire to your PC with a USB cable, and Microsoft has something called Active Sync, and it simply moves the file over for you immediately, or you can just drag and drop it, just like you would any other disk. Okay, let's have a look at the other menu option here. So this is the one where we can choose what we want for breakfast, lunch, or dinner. I'll just pick a new name here, so maybe I don't have any selections yet. So here's Marion Boyle, I guess is her name, in room 125A. Does she want scrambled eggs? There's something called what we call auto advance here. I'll just set that off for the moment. Auto scroll rather. So I've got some options. So you can either make this thing advance as you click or not. Just stay in one place and you do the scrolling. So every time I click on an item, the red arrow indicates that I've chosen that item for that person's breakfast tomorrow. So I just go through and I click a few items, and eventually I decide that I've clicked enough. I can click on this button, Menu, and I can just see a summary of what I've chosen for that individual. And I can say, okay, Marion, is this what you wanted? Yes, thank you. Okay. So again, the interface itself, we try to keep it as simple as possible. This one's a little more complicated because it has tabbed elements. You've got breakfast, lunch, dinner, supper tabs there, and a few other bells and whistles compared to the other one. So that's about it. Yes, question?
This means came from the station?
Yeah, the base station is where you design the options, I guess. So the person who keeps track of the facility food inventory would know that on Tuesday next week we're getting a shipment of I don't know, chicken breasts or something. So I'm going to put chicken breasts on the dinner menu. So that goes into the base station planning, and then it generates these options. Well, sort of by resident, because it's a bit of a combination of several factors. Each resident has, as I said, certain nutritional requirements. Some of them may be vegetarians, diabetics. Some of them need their food has to be pureed. They can't chew it. So that information is combined with the food options. And so often there's several choices for each. That's why we've done it this way. There's several choices for each category. So, and yes, it's but each resident's view of that could be slightly different, because some people simply won't even come up as an option if they're vegetarian to put chicken on their tray, basically. Yeah. If they want something else, that's, I believe we tried to allow that with that add button there. Let's see if it works. Okay, I guess I need to actually select an item first. So I'm not sure if this is complete. I can't remember how far we got with this, but basically, if the person didn't see an item that they really wanted, there was an attempt to allow extra items to be added to the list, basically that way, yes.
Even if it's not good for me.
I don't know. That's where it gets beyond my level of expertise and how they use it. I don't know. The nutritionist would probably have to play that one according to his or her rules, you know. Yeah. Okay. Any other questions or concerns? So it's a challenge. Does anybody have any other little applications? Is there another item on the program of the conference about Pocket APL? Yours, yeah. Okay. Well, I'll leave you to talk about that when you get to it. That's great. But as far as I know, there's not too much commercial activity with the product yet. Just this.
So when all this information is uploaded to the main PC, and then you said that they print out with the menu for the next day, is the print ticket?
Yeah, they actually print tray tickets, as they call them. Yeah. So
I was wondering if there was any kind of optimization that was done so that instead of having to look at, again, I don't know what their kitchens are like, but maybe instead of making 3 different separate orders of scrambled eggs, they make one big batch and then serve it out. That way it's kind of more optimized for there and makes them.
I believe there's some coordination with the the food inventory. As I said, they know they're getting a truckload of chicken breasts or whatever. So the recipe database is scalable. So they know they can do 100 orders of scrambled eggs. They know how many eggs goes into that. Some of them are quite complex. Like if you're making a chili or something, you've got X number of cans of tomato sauce and X number of pounds of ground beef and so on. These recipes.
So on the main PC, they can enter all their recipes in there?
Absolutely, yeah. That's been there for years. This system's been around, I think, a couple of decades, and so that's already been well thought through and well designed, I believe. Yeah. Yeah. Okay. Anything else? If not, then thank you.
Okay. Thank you, Richard.